welcome to another one of our videos from Chapter 8 dealing with hypothesis testing. This one is for a standard deviation unknown. So just like whenever we did our confidence intervals, sigma unknown meant that we were going to use a t-score. So just like then, we're going to do the same situation. We want to look at an example now and see how that goes. So got a random sample of $1 trifecta tickets at a local racetrack, following amounts dollars and cents. Is there sufficient evidence to conclude that the average trifecta winnings exceed $50? And we are to use 10% and assume that it's normally distributed. That means we can go to our table. Thing to note, n is 12, x bar equals, and for these types of problems, just enter your data into the calculator list and let it tell you what it is. In this case, it's a 67.95, and S is 53.06. Those are what will be needed for our hypothesis testing. And we've got the same steps as before. We've got that hypothesis statement. Which consists of our null hypothesis and our alternative hypothesis. The null hypothesis, we are always using u equals. And then the alternative, in this case, they're asking exceeds 50. So greater than 50. Does it exceed 50? So 50 is our mu, mean that we're dealing with. They are asking, does it exceed? So this is our claim. This is then one-tailed. The look goes that sort of scenario, with the top part being where we're going to have our critical region. With a t-score here rather than a z from before. Our second step is our significance level. And that's alpha, and in this case that is a 0.10, 10%. Our third step is to find our critical values. In this case, that's just critical value because it's a one-tailed test. And it's a t, so we need our degrees of freedom. And degrees of freedom, if you'll recall, n minus 1. So in our case, that is 11, 12 minus 1. So just like before, we have to go to our table. So if we look at this, we'll see we were doing the one-tailed 10%, one-tailed 10%. So down that column. And we were dealing with an 11 degrees of freedom. That's the 1.363. 1.363. So our critical value, 1. Critical value of a 1.363. And just like before, our next step is a test stat. And instead of saying z equals, it's t. We still do our sample minus our mean over, well, we don't have sigma, so it's s, over our square root of n. For this example, that's a 67.95 minus our 50 over 53.06 over our square root of 12. Calculating that out, you will get a 1.1719. Now we have to compare that to our critical value. Our critical 1.363 and our 171 piece, or 1171, is down in the non-rejection region, the non-critical. So step 5, we do not reject the null hypothesis, H sub 0. And like I've stated before, it's always the null hypothesis that you are rejecting or not rejecting, not a claim. That's dealt with in this last step, which is the summary. And based on that and what we had written as our null hypothesis, that would be there is sufficient evidence to indicate the mean winnings exceed $50. That was basic concept. We didn't agree with the null hypothesis, so that means pretty much we agreed with the alternative, which states that it does exceed. So that's our example with t-scores, and we'll be back with another one.